This is a problem of superposition theorem for AC network. So determine voltage across 2 plus 5J using superposition theorem. They may ask current also. So procedure is same only. So now let us do this problem. Determine voltage across 2 plus 5J, this branch, using superposition theorem. So let us find out how many sources are there. First, there is a 50 angle 0 volts. So this is a voltage source. So this is a voltage source. This is 20 angle 30. It's a current source. Amp A is given. It's amp. And arrow mark also you can see. Arrow mark means it is a current source. It is a voltage source. So two sources are there. One is voltage source and one is current source. We need to find out what is the voltage across 2 plus 5J, this branch. Okay. Through this full branch. 2 plus 3J, 2 plus 5J. What is the voltage? That you have to calculate using superposition theorem. Superposition theorem states that overall response is equal to algebraic sum of individual response. So what is a response? That is what is the voltage given by this 50 volt source alone? What is the voltage given by this 20 at an angle 30 amps voltage current source alone? So after that we have to add response due to this, that will give you the overall voltage at this point. Let us consider the first case, that is consider only 50 volt source alone. So it's a problem on AC source. When I consider the first voltage source, I want to make second voltage source is equal to 0. So second source is actually current source. I have to open here. If I open means how to make current source equal to 0, you have to open circuit. If you open this, if that means you have to just remove this from the circuit. If you remove it, the second end of J2, the second end of J2, the second end of J2 is not at all connected. So it is just hanging, just you have to remove it. J2 also will go, because if I remove this circuit, there is no connection to this. So this is just hanging. So you can no need to write this also. So you left with only this part. So you have to find current here. Okay. If first you have to find current, then multiplied by 5 plus 2j will 2 plus 5j will give you voltage value. Okay. If they ask only current, this is the voltage divided by this much. Okay. So let us do now. It is a voltage, no? So current is given by 50 divided by 5 2 plus 5j plus 4j, 2 plus 5j plus 4j. So how to do this using calculator? You open a calculator. Okay, I'll do it now. So first, if you want to perform any AC network, you should be in complex mode, and before that you should be in degree. You check whether it is in degree or not. Go to setup. Our third option is degree. If already D is displaying, no need to change. If any R is there, that means radian. You have to change it to degree by selecting third option. Now it is also D. Already it was also D. Now also it is D only. You please check your calculator. If it is D, don't do anything this setup. Just continue. Otherwise, if any R is there, go to shift setup and select third option degree. So D should come here. Now press mode. Is a mode button. Press mode and press complex, select complex. The option is 2. So click on 2. Now it will show CMLX complex, CMLS complex, CMPLX complex is also displaying. Degree D is also displaying. Now I have to perform this 50 angle 0 divided by this. So take this denominator, this fractions. In the above, I want 50, shift this minus symbol, 50 angle 0 degree. Denominator is 2 plus 5. J means actually I button. This ENG button you have to click. 5i plus 4i. Okay. This will give you current. If they ask current through 2 plus 5j, you need to write only this much. This is the current value it will give. I dash only. You can easily find out. Okay. This will give you, click SD button. It will give you 1.17 minus 5.29. This is in rectangular coordinate. Okay. Rectangular coordinate. Okay. If you want the answer in polar coordinate, shift, again you click complex. Third option is polar. So this is the current value. Click SD button. 5.42 angle minus 77.47. If they ask find current through this instead of voltage, if they ask current through 2 plus 5J, this is the current value. But here they ask voltage. So this current multiplied by 2 plus 5J. Because how much current is flowing and we have to calculate only across 2 plus 5J. So this current value multiplied by, because we are measuring across this V dash, only across 2 plus 5J. So this answer multiplied by open bracket 2 plus 5I. This will give you 470 and this is a click SD button. It is 28.82, 28.82, or all of you see here in the screen also 28.82 minus 4.70 I. That means I means J. This is, you have to keep both the answer in rectangular as well as polar. So how to keep the answer in polar means, again if this answer is coming now, again click shift, there is a complex is written here, complex, and third option is rectangular to polar. And if you want the answer in this format, you have to select fourth option. Okay, now already we are in A plus BI format. I want the answer in third option, and this is going to give you 29.2, 29.2 angle 9.2726, 9.2726. So this is your V dash. That is the individual voltage response due to this voltage source. Now I have to calculate what is the voltage because of this current source acting alone. When you consider this source 20 angle 30 current source, you have to make this voltage source is equal to 0 by short circuit. You have to make this voltage source is equal to 0 by short circuit. Okay, this is shorted now. It's a current source. You can apply current division formula. You can apply current division formula so that you will get here what is the current here. What is the current here? So here they used a different technique. I'll use another technique so that I can apply current division formula. Please see here in the notes it is different. I will use different method. Current in this branch is equal to, I'll write now what is the main current, 20 angle 30. So write 20 angle 30, 20 angle 30 is the main current into impedance opposite to this. Impedance opposite to 2 plus 3J is because this voltage source is shorted, 20 amps current is flowing and it is divided between two paths. It is going to divide between two paths. I want to find current in this path. So you can use mesh analysis, you can apply nodal analysis, you can apply any technique. You have to find current and voltage here. So you can apply any method, no problem. Now, this is a main current, 20 angle 30 is a main current. What is the impedance opposite to 2 plus 3J is 4I. So 4 into I divided by sum of all. Okay, sum of all means 2 plus 2 plus 5I, 2 plus 2 plus 5I, 2 plus 5I plus 4I. That is a total. Or you can directly write 9I also. So this is actually 6.39 plus 6.39 plus 5.8986I or J. So this is in rectangular coordinates. I want the answer in polar. So shift complex, third option. It is going to give you 8.6 angle 42.5. Please note down 8.6 at an angle 4.2. 8.6 at an angle 8.6 at an angle 42.5. That is the answer. You have to get. They used here different. Okay, don't do this. I think this is the correct answer because if you use this one, you have to do a lot of calculation. Okay, this is they calculated only I1. Please see here they calculated I1. Actually, current through this one is you have to take difference of these two. So this part is wrong actually. So this is the correct answer. Okay, this is the correct answer, which is current through this current through this due to this 20 angle 30 angle. Due to this current source, we applied current division formula here. So we calculated current through this, and this multiplied by 2 plus 2j. This multiplied by 2 plus 2j is actually the voltage. So this answer multiplied by 2 plus 5i. Okay. So this is 46 angle 72. 46 angle 72. 46 angle 72. It's not completed. So 46 minus 72 at an angle 1110. So that is V double dash. That is V double dash. This is V dash is individual response from voltage source. Please note down. You continue what I showed in the same thing. You can copy in the notes. Due to 20 angle 30, the current we calculated then multiplied by 2 plus 5j will give you 46.72 at an angle 110.72. That is a V double dash. After that, we have to overall response is what? Overall response is V dash plus V double dash. V dash plus V double dash. V dash value is already calculated properly. It is 29 plus 29.2 angle minus 9.2. No, so this is V double dash is already there. So for that, I am going to add this also. For this answer, I am going to add first response, that is 29.2 angle minus 9.2726. So the answer is 12.28 angle 38.99. This is the final answer in rectangular coordinates. If you want, you can see the answer in polar coordinates. So it is 40 at an angle 72. Okay, 40 at an angle 70. Let us verify whether it is correct in the textbook. So find voltage across 2 plus 5j. You can see I did same thing. So first we got we opened the current source here. Okay, this becomes a dummy. So current through this one is 50 angle 0 divided by 2 plus 4j plus 5j. So we got this answer. It is a current, and voltage across this is this current multiplied by 2 plus 2j, 2 plus 5j, 2 plus 5j, and multiplied by this current will give you, this is your V dash. And I consider current source, voltage source is short circuited, and you have to apply current division formula. Okay, in the current division formula, we calculated same current only, we got this current. Okay, yeah, the current division formula is 20 angle 30. Impedance opposite to 2 plus 5j is 4j divided by sum of this 2 plus 5j plus 4j 9j. This will give this answer, and this is the current value. This current multiplied by 2 plus 5j, current multiplied by 2 plus 2j is 46.69 at an angle, and same answer we got. And after that, we have to add 8.6. We have to add V dash and V double dash. V dash is 29.16 at an angle minus 9.28, and we have to add with 46.69 at an angle 10. And if I add both You should get 40.85 at an angle 78.5. Think we got the same answer. 40.88 at an angle 72.52. Okay. You copy this. Okay. Instead of that notes, printed notes, you can continue this part. Okay. Part B option, instead of going for mesh analysis or something, current division is easily you can find out immediately. Okay. So this part, this is easy compared to that. Thank you.